Hello children, in a previous class we discussed what is a function, what is a differentiation and what is a differential coefficient and differential operator, and we also discussed geometrical interpretation of differential coefficient. Children, link is given in the description. Kindly go through it, because having the knowledge of differentiation, that is understanding the concept of differentiation, is very important. So before going to start today's class, actually let us recall the few important points which we discussed in the previous class. So look at here children, when y is a function of x, then we can write y is equal to f of x, which means what is children here? Here x is a independent variable and whereas y is a dependent variable. Is that clear? Fine. Next, what actually differentiation is? Children, differentiation is a branch of the mathematics which deals with the comparative study of differences of two variables. Then how can we define a differential coefficient? Differential coefficient of y with respect to x can be defined as a ratio of difference in y to the difference in x subjected to delta x tends to 0. It's very important. Means delta x should approach 0. That much very small value should be. Then only you can write delta y by delta x as dy by dx. It also can be written as limit delta x tends to 0 to f of x plus delta x minus f of x by delta x. Why? Because f of x is nothing but what children? It's a y only. And this you can write as a y plus delta y. Again same thing you will get, that is delta y by delta x. And one more very important point regarding this differential coefficient is that, so with the geometrical interpretation children, we got a conclusion, two conclusions which we got. In that first conclusion is differential coefficient at any point may be defined as the slope of the curve at that point. Okay children, fine. And the last one is what? Dy by dx. What is this dy by dx? Differential coefficient of y with respect to x. It is also called as instantaneous rate of change in y with respect to x. Here variable y and x, it can be in any other way also. For example, if we have a displacement time graph, then we can write the rate of change of velocity with respect to time. For example, what we can say now, velocity time graph, not a displacement time graph actually. This what actually we can call it the acceleration. What acceleration? Instantaneous acceleration. Instantaneous acceleration. Whereas in a displacement time graph, the rate of change of displacement with respect to time is what actually? Instantaneous velocity. So this is how actually we can define differential coefficient of y with respect to x, or else differential coefficient of s with respect to time, differential coefficient of velocity with respect to time. So this is what the children is a instantaneous what actually? Acceleration. This is what? Instantaneous speed. Okay, so these are the very important points which we covered in a previous class. So again I am telling you children, link is given in description. Kindly go through it so that you will get a nice command on the concept so called differentiation. In today's class dear children, we are going to discuss the theorems of differentiation, that is rules of differentiation. So here we will discuss children, one by one we will discuss, because these are very important to understand, with which only we are going to solve a numericals given. Okay, so let us write theorems of differentiation. Theorems of differentiation. So children, under this, the first one, it's a very simple, at the same time it's very important. That is, for example children, for suppose the first theorem of differentiation, or you also can call this first rule of differentiation, nothing is wrong in it. Okay, so for suppose children, if y is equal to c, if y is equal to c, then here what is c children? It is an isolated constant, an isolated constant. Now what is the differentiation? What is the differential coefficient of y with respect to the x, let us say? So if y is equal to c, so dy by dx, this can be written as d by dx of C. So let me tell you, first I'll let the answer, then I'll give you explanation. So this is going to be a 0. So here you may get one doubt. Sir, why a differential coefficient of an isolated constant is 0? The reason is that, children, first let us try to understand in a previous class which we discussed dy by dx, which means what? As x changes, y value must change actually. Y value should change actually. Okay, then only we can calculate the differential coefficient of that function actually. Means this y must be a function of x. Y must be a function of x. But here C is what, children? It is an isolated constant, which means what? It does not depend on any other variable. Though you can change the x value, or if you do not change the x value, nothing makes difference in the C value. It's very, very important. For suppose, children, in a previous class, we have taken one funny example. What was that? So when we are changing the position of the regulator, the speed of the fan changes. It's clear. But you tell me what happens when we go on changing the regulator position to the intensity of light. Will there be any change in the intensity of light when you are changing the regulator position? No, obviously no. Whether you can change the regulator position or not. Okay, na? That intensity of light won't get affected. Why? The intensity of light does not depend on this regulator position. As it is not, depending on the regulator position, definitely does not depend. So then what will be the rate? The rate of change will be 0. The rate of change will be 0. So that is the reason why d by dx of an isolated constant is 0. Let us take one example so that it will be very clear to us. Example. So d by dx of some number phi is equal to how much? Children, do you think that when with value of x, phi value will be changing? No, that is a constant always. Whether you can increase the x value, we can decrease the x value. When you can remain x value is a constant also. Nothing makes difference in phi, right? It always phi. Then what will be the rate in a what will the rate of change in y with respect to x? Means 0. That's it. So let us take one more example. D by dx of pi value. Let us take pi. Pi is also constant. It does not depend on x value. So the rate of change of pi is what? Again with respect to x, it's a 0. So it's very, very important thing is that, so whenever a constant is there, when you want to apply the differentiation, that is the d by dx, the result will be 0 only, which means what, dear children? The differential coefficient of an isolated constant is always 0. This is the first theorem of differentiation, or you also can say that it's a first rule of differentiation. Hope it's clear, children. Just copy it so that we can move to the second theorem. Okay, fine. Now, children, let us go to the second theorem. For suppose if y is equal to, let us say, u plus or minus v plus or minus so on like this. Let us take n number of variables such a way that u comma v and so on other w x y z whatever it may be there. Okay, now they all are the function of x only. It's very, very important. So here u comma v, let us take even w also. These all are the functions, children. It's very, very important. These all are the functions of x. Then what will be its differential coefficient? So the differential coefficient dy by dx, it can be written as d by dx of u plus or minus v plus or minus w plus or minus up to so on. So then what will happen? You can apply this d by dx to the each and every variable and which is the function of x. So this is going to be, children, that is dy by dx can be written as du by dx plus or minus dv by dx dw by dx plus or minus so on. Children, what does it mean, children? It means that if you can see here, the differential coefficient of algebraic sum of the number of variables, number of functions which is equal to the algebraic sum of the differential coefficient of individual functions. Am I clear, children? So which means what? When differential coefficient is there, inside if n number of functions are there, so you can apply this differential operator to the each and every function individually. Hence, it can be calculated. Let me give an example for this. For suppose, for a second example, if you can take example, for example, y is equal to, for example, x square plus x cube minus x power 4, something it is there like this. Okay, then dy by dx can be written as d by dx of x square plus d by dx of x cube minus d by dx of x power 4. Of course, how we can calculate d by dx of x square x cube, that we will see, but this is how actually we can expand that. Okay children, just copy it. Now let us see the third theorem of differentiation or third rule of differentiation. So children, look at here, this third one. If y is equal to x power n, let us say, then how can we get the differential coefficient of y? If y is written as y is equal to x power n, that is dy by dx, it can be written as d by dx of x power n. But how can we obtain this differential coefficient? Look at children here. So the differential coefficient of x power n, it can be obtained like this. So here x power n is there na, so just you decrease the x power n by 1 actually. So we have to decrease the power of x by 1, that is x into x power n minus 1. So try to understand. Here x power n is there. What we are doing? We are decreasing its power by 1, that is x power n minus 1, into multiply this with the power. His power is how much here? N is there. That is n into x power n minus 1. Children, this is a most important, which we are going to use this like anything actually. Many places we are going to apply this formula. Simple way, it's a very simple manner we can do it actually. So let us take a few examples so that we will get an idea. Okay children, fine. So let us do here examples. So for suppose if y is equal to x square is there, y is equal to x square is there, then what is the differential coefficient of y here? So that is, just write in this formula, that is dy by dx, it can be written as d by dx of x square. Now you compare with this formula children here. So x power n, here x power 2 is there. So here in the place of n, 2 is there. That's it. This is what actually we have to understand. So here d by dx of x square can be written as the power into, that is n into, so that is 2 into x power, you decrease its power by 1, right? That's it. So x power 2 minus 1 will be x power 1, that is x only. So this we are going to get as a 2x. Okay, the simple example we are taking. Children, it's not that how complicated example you are going to take. It's not that actually. Whether we are understanding or not, it's very important. Once you can understand, you can go to any extent. Okay, children, it's very important. Okay, so let us take one more example. So here let us include even second theorem of differentiation. So that is y is equal to whatever just I gave example, x square plus x cube and minus x power 4 is there. And then what we have to do, let us apply the formula, that is differential coefficient of y, it can be written as d by dx of x square plus x cube minus x power 4. Now as per the second theorem of differentiation children, this can be applied to the individual function we have to apply. So this is going to be d by dx of x square plus d by dx of x cube minus d by dx of x power 4. Now what we have to do children? Again, let us go back to the same formula here. That is what? D by dx of x power n is equal to n into x power n minus 1. So here in the place of n, what is there? 2 is there. But in this function, in the place of n 3 is there. Here in the place of n 4 is there. So what? Let us apply the same formula, we will get the result. Look at here, that is 2 into x power 2 minus 1, that's it. Here plus this is power into x power, you decrease its power by 1, that's it, minus here 4 into x power 4 minus 1. So let us write the answer here, 2x plus 3x square minus 4x cube, that's it. So this is how actually we can apply this formula. It's a very important, it is very much important. So d by dx of x power n can be written as n into x power n minus 1. So this is what actually third theorem of differentiation. Is it clear? Then fine. Now fourth one. For suppose, let us take if y is equal to c into x power n is there. Here what is c here? C is an isolated constant. If any function is multiplied with a constant, then how to calculate its differential coefficient? It's very important. If it is a product, okay, it is multiplied with a differential, what we can say, an isolated constant, then how can we calculate how can we find the differential coefficient of this function? Just look at here, it's very important. That is dy by dx is equal to d by dx into c into x power n. First you write like this. But children, c is what here? As I said, is an isolated constant. Differential coefficient of an isolated constant, what actually 0, which means what? Constants can't be differentiated. Then what we have to do? It can be written as, children, dy by dx. So kindly take out this c out of this differential operator, c into d by dx of x power n. Again here d by dx of x power n you can write as usual actually. Okay children, this is how actually we can write. Let us see one example so that you will understand. Hope it is copied children. Fine. See here, let me write here. Example let us take. So for an example for fourth theorem. Look at it. Let us see the example here. If y is equal to 4 into x power 3 is there. So how to calculate the differential coefficient? That is dy by dx is equal to d by dx of 4 into x cube, children. Here 4 is what here? It is a constant, just you take outside. So this is 4 into d by dx of x cube. So here how to calculate this one actually? Again apply the same formula here. That is 4 into, separately you can write, this is going to be 3 into x power 3 minus 1. This is going to be 4 into 3x square. Now you multiply 4 with 3, then you will get 12x square. Okay children, so this is how actually we can apply the fourth theorem of differentiation, so called fourth rule of differentiation. Just you copy it. Now let us see the fifth theorem of differentiation. Children, it is also very important. So look at here, fifth one. For suppose children, if y is equal to u into v. Children, here u and v both are functions of x. You should not forget that. It's very important. So then differential coefficient of y with respect to x, how you can write? So this will be d by dx of uv. Children, it is also called as product rule. Very important. It is also called as product rule. It's famous, very famous as a product rule. So children, here u is a first function, v is a second function. It's very important. So it can be written as first function into differential coefficient of second function plus differential coefficient of first function into just second function. So this is how actually we can write. Let us see an example how it can be applied. Then what will happen? We will get a good command. For suppose children, example Let us take example. Y is equal to x square plus 1 into x plus 1, let us say. So we have to calculate the differential coefficient. So it can be d by dx of x square plus 1 into x plus 1. So children, don't you think that it is in the form of d by dx of uv? Yes, it is in that form. Then we have to apply the product rule. First, let us identify which one is the first function, which one is the second function. Children, it is a first function, it is a second function. Now let us apply the formula. That is first function into differential coefficient of second function plus differential coefficient of first function into second function. Now let us apply the as usual it is. This is going to be x square plus 1. Children, according to the second theorem of differentiation, this can be applied inside. Okay, now fine. So it is going to be dxy dx plus d by dx of 1 plus, okay na children, this is just multiplication. You are applying a differential operator to this x square plus 1 only. So this is going to be d by dx of x square plus d by dx of 1 into, as usual it is, x plus 1 is there. X plus 1 is there. Let us write from here. This is x square plus 1. Children, dx by dx value is how much? Generally what will happen, you know, of course many lecturers will tell that d by dx of x is 1 only. They'll tell that this they'll get cancelled, but that is not the correct way to cancel actually. Then how to look at here? So children, it is d by dx of x, means what here? X power 1 is there actually. Okay, now so this can be written as its power into, its power is reduced by 1. So this is going to be x 1 into x power 0. X power 0 value is how much children? 1. So this is going to be 1. This is how actually we have to apply the concept. Okay, now fine. So here dx by x value will be 1 only, and d by dx of 1. Children, differential coefficient of what? This is a isolated constant is 0, that is plus 0 and plus d by dx of x square. Let us apply the d by dx of x power n formula, that is its power into x power 2 minus 1 plus again d by dx of 1 is 0 into, as usual it is second function is there. Let us simplify this children. This is going to be x square plus 1 plus this is going to be 2 into x power 2 minus 1, that is 1 only. This is going to be 2x, this will be x plus 1. So actually till here we got the answer. If you want, you can simplify more, that is x square plus 1 plus you multiply inside, this is going to be 2x square plus 2x. Now 2x square plus x square, this is going to be a 3x square plus 2x plus 1. So this is the answer. Children, again I am telling you, whether you can take this example or any other example, the thing is that we need to understand how to apply the product rule. Now let us see the sixth theorem of differentiation, that is the sixth rule of differentiation. Sixth one children. So here if y is equal to u by v, and children u and v as usual they are the functions of x, then how can we calculate its a differential coefficient, that is dy by dx, it can be written as dy by dx of u by v. Children, it is also called as quotient rule actually. So according to this children, d by dx of u by v, it can be written as children, it's very important. Look at here, this is a first function children, it is first function and it is a second function, it's very important. So here second function into differential coefficient of first function minus first function into differential coefficient of second function by square of the second function. Actually, it's very important. So this is also called as quotient rule. This is also called as quotient rule. So previously whatever we learned is a product rule and it is a quotient rule, children. Is that clear? So first you should identify which one is the first function and which one is the second function. Then it will become very easy to us to apply the concept. Now we will see the example. Let us take a simple example, children. Let us take a very simple example to understand how to apply this quotient rule. It's very, very important. So children, let y is equal to, for suppose it is x square by x plus 1 is there. X square by x plus 1. So its differential quotient, that is dy by dx, it can be written as d by dx of x square by, children, it is a x plus 1. So here first you have to identify what is the first function, what is the second function. Children, here x square is u, that is the first function, and x plus 1 is a second function. Now let us apply the formula first, then you can simplify later. So according to that, children, second function into differential coefficient of first function minus first function into differential coefficient of second function by square of the second function. Now let us simplify, children. So this is going to be x plus 1 into, children. So d by dx of x square, just we have done, its value is going to be 2x. Children, let us apply the d by dx of x power n. Okay, so this you will get as a 2x minus x square into, this you can apply, children, d by dx you can apply to this x and you also can apply to the 1. So what is the d by dx of 1 value? Is going to be 0, but d by dx of x is how much? It is a 1, that is into 1 by x plus 1 whole square. So this is going to be, just you multiply with this, children, 2x into x, it is going to be 2x square, and 2x into 1 will be 2x minus x square by it is x plus 1 whole square. So 2x square, here 1 minus x square is there, it is going to be x square. So this is x square plus 2x by x plus 1 whole square. If you want, you can do more simplification. But the thing is that here what we are trying to do, we are trying to apply u by v formula, that is so called quotient rule. Children, again I am telling you. So d by dx of u by v is equal to second function into differential quotient of first function minus first function into differential quotient of second function by square of the second function. Is it clear, children? Just copy it. Seventh one, children, it is also called as chain rule. Of course, it is chain rule. It is chain rule. For suppose, children, so y is written as u square plus u plus 1, and don't forget that u is a function of x, must be a function of x, then only we can calculate a dy by dx actually. Okay, na? So and here u is given as x square plus 1. They are asking us to calculate actually dy by dx is equal to actually how much. So now, children, first step what we have to do, let us differentiate y with respect to the u. Is going to be a d by du of u square plus u plus 1. Is that clear? So it can be d by du into u square plus d by du of u plus d by du of 1. Anyhow, this is going to be a 0, this is going to be a 1. Is that clear, children? Fine. Now this is going to be how much? D by dx of x square, x power n formula you can apply. So here you will get it as a 2u plus 1. This is we got dy by du. But children, u is a function of x, it is given. U is a function of x means it must be differentiated in terms of x, that is du by dx is equal to d by dx of u is what here? X square plus 1. Just you apply inside, this is d by dx of x square plus d by dx of 1. Anyhow, this is going to be a 0. Differentiation of constant is always 0, and this is going to be get, it is a 2x. So it is du by dx is equal to 2x we got. Here dy by du is equal to we got. But what we have to calculate? Dy by dx. Children, here dy by dx, can you write like this? dy by du into du by dx. Yes, of course we can write. Now we know this dy by du and we also know du by dx. Just you substitute here, you will get it. That is what here, 2u plus 1 into 2x. But children, y value is what? Y value x square plus 1. You substitute in this. So you are going to get 2 into x square plus 1 into 2x. If you want, you can simplify more also. If you want, you can simplify. What you will get if you will simplify? You will get 2x square plus 3 into 2x. Still you can simplify. Further also you can simplify this. But our intention is what, children? To know the formulae and how to apply the formulae. This is called actually chain rule. Means whatever is given, we have to differentiate, and whatever you are written in terms of x, that must be differentiated once again. We will do one more numerical so that you will get a clarity. First you copy this. We see one example, children, so that we get a more clarity. For suppose, children, here y is equal to, let us say it is x cube plus x square plus 1 to the power of 5, let us say. Now we need to calculate, they are asking us to calculate the dy by dx is equal to how much? Dy by dx is equal to how much, children? So children, it's a very important thing is that, so whatever is given is a function, let us assume it as a t. Let us assume it as a t. T is a function of x. So here what actually? T is equal to x cube plus x square plus 1. Means t is a function of x. Okay, na? Fine. So it can be written as now y is equal to t power 5. So now this can be differentiated, y can be differentiated only in terms of t only. That is dy by dt is equal to d by dt of t power 5. So children, in a single terms, children, you have to differentiate this into whatever you are assuming. It is either t or some other variable. That must be differentiated once again. You have to multiply with that actually. Then we will get it. Okay, let us do it so that you will get a clarity. So dy by dt. So children, as per the formula x power n, this can be written as 5 into t power 5 minus 1. This is going to be a 5 into t power 4. This is what, children? dy by dt. Just keep aside. Now come back to this one. Whatever we assumed as a t is what? D is equal to x cube plus x square plus 1. Let us differentiate this t in terms of what? X. That is dt by dx is equal to d by dx of x cube plus x square plus 1. Let us apply this d by dx according to the second theorem of differentiation. This is going to be written as d by dx of x cube plus d by dx of x square plus d by dx of 1. Anyhow, children, this value is going to be 0. Differential coefficient of isolated constant is always 0. So children, if you can apply here x power n formula, you will get 3 into x power 2 plus here you are going to get a 2x anyhow plus 0. This is what, children, it's a dt by dx. But what we have to calculate? We have to calculate dy by dx. So dy by dx, children, dy by dx, it can be written as, this is dy by dt into dt by dx. Am I right? So dy by dt value we have, dt by dx value which we have. You can substitute here. You will get here 5 into t power 4 into 3x square plus 2x. Now children, anyhow, you substitute the t value, this here, this value you can substitute here. That is 5 into x cube plus x square plus 1 into 3x square plus 2x. Okay children, this is how actually we have to apply the chain rule. Okay children, just copy it and we will see the differential coefficients of trigonometric ratios. These are very important. Just copy it. Is equal to. Now children, now let us see the differential coefficients of trigonometric ratios. But why I wrote here 3, here 3, I will tell you after writing this, children. So here d by dx of sin x is actually cos x and d by dx of tan x is secant square x and d by dx of sec x is secant x into tan x. Now come here children, d by dx of cos x is minus sin x, d by dx of cot x is minus cosec square x, d by dx of cosec x is minus cosec x into cot x. Okay children, fine. And here you may get a doubt, sir, how can you write directly d by dx of sin x is cos x, d by dx of cos x minus sin x? Children, by applying the first principle, you can calculate the differential quotient of sin x as a cos x. Children, next class I'll try to do it. At least d by dx of sin x, cos x and tan x, we'll try to calculate the differential quotient, these three, sin x, tan x and cos x, so that you will get idea. Actually, examination point of it is not important, but you may get one doubt, sir, how can you write d by dx of cos x as a minus sin x? Yes, for that we have a derivations actually, not to worry about that. In the next video, I am going to calculate the differential quotient of sin x, tan x and cos x, so that you also will get a confident. Now children, here why I wrote separately means here small trick is there. Here these are all the differential quotients of the trigonometric ratios which will start with the letter C. Why I am writing this here? So the differential quotients of trigonometric ratios which will start with the letter C, in their result negative sign will be there. Negative sign will be, it's very important, whereas here negative sign won't be there. So sometimes students will have a confusion whether is it d by dx of sin x is minus cos x or d by dx of cos x is minus sin x. They'll be getting confused. For that children, just you remember, if you think that it is useful, you can remember, or else if you have any other better way, yes, you go ahead. It is not compulsory that you should follow whatever I am telling you. So this is what actually how I feel a comfort. So the differential quotient of trigonometric ratios which will start with the letter C, in their result you will get a negative sign actually. Okay children, fine. So these are the seven rules, 7 theorems of a differentiation. These are very important. So children, once again I am telling you, in a previous class we covered what is a function, what is the differentiation, what is the differential coefficient, what is the differential operator. Those points are very important. Again I am telling you, link is given in the description children, kindly go through it so that you will get a command. Children, learning subject means it's not just by hearting d by dx of y is what, it's not that actually. First you should know the meaning. As you are writing dy by dx means what does it mean? When you are writing y is equal to f of x, what does it mean? So those things are very important. And as usual, in today's class we covered a main important theorems which are important for a differentiation. So these are the theorems of differentiation which we are going to use in order to have some calculations. Okay children, thank you so much, all the very best.